Hello, I'm Oscar, Product Specialist at Ommatidia LiDAR, and I will walk you through the basic workflow for taking metrology and vibrometry measurement with our Q2 series laser radar. The Q2 has an embedded Windows PC and an Ethernet port, and it needs to be operated through an external computer connected via remote desktop. We can connect the Q2 directly to the controlling computer or to a local network, so we can operate it either by being physically on the same network or through VPN if working remotely. Once the Q2 is turned on and in the same network as our computer, we just need to open the remote desktop, log into the device, and let the operating system start. When that's done, we just need to open the Atelier software that comes installed with all of our devices, and we'll be ready to start measuring. Once Atelier has loaded, the first thing we want to do is open the visualization camera in order to see the object that we're going to measure and proceed to configure the scanning path and the focal distance. You can see that in this case, the device under test, the DUT, is a speaker. Also, notice that on the right-hand side of the speaker, there is a line of green points. This indicates the position of the 65 laser beams that the Q2 has available for measurements. What we want to do now is determine the angular range for scanning this object. In this case, I got lucky since the beams are already aligned with one of the edges. From this initial position, negative angles will rotate the Q2 counterclockwise and positive angles clockwise. I like to perform scans in a clockwise direction, but this is merely a personal preference. So minus 12 degrees is a good angle for starting, so we'll then put this value as initial angle and then put 0 degrees as the final angle. It's also important to specify the distance between the Q2 and the DUT so that the laser beams are correctly focused. The minimum working distance is 85 centimeters, and I've set the speakers 85 centimeters away from the Q2. So in this case, I don't need to change this value. Now we're set to start scanning. As best practice, we always start by performing an intensity scan, which will show us if we are getting enough signal back from the DUT. This is a quick scan that will give us an image and a histogram of the received signal's intensity. We can now see the image from this scan and notice that all of the received signal is larger than 60 dB. 60 dB is an appropriate threshold to ensure that the quality of the signal is good. If the signal is weaker than that, it might be worth trying to improve the reflectivity of the surface, for example, by applying reflective paint. In this case, we're good, so we can go on to the next step of the workflow.